FRQ. Yeah, and then the benefit.
Okay, so what I'd like for us to do today, I've checked all the way up to 2019, so there's 2016, 2017, 2018 remaining. Each day until Thursday, I'll still be checking those 6 FRQs. But today's gonna be the last day that I want to spend class period having us focus on FRQs. Starting tomorrow, I want to start using class time to pick out problems from the packet 6. So packet 6 will be due whenever you're finished with it. It's a required completion grade. But you can wait till the last day to turn in. For seniors, grades are not due until the week after the last day, so you have that flexibility to turn in into next week, and then if you're not a senior, you can wait till the last day to turn it in if you wanted to. But I do need to see that your work. I do need to see that you're showing me that you're working through each problem for full credit. Right? But still should be easy grades. Let's spend time working through it. Let's see. I want to maybe highlight some problems for us to try. Okay, let's go to page 31. Let's do a polar problem. I think I'm just going to alternate between polar and Taylor series for our last day in class, and the rest we can. Oh, I am having help sessions each day before school, after school, and advisement. But it's for my AB students. But if you want to come in, sit in, and ask questions, I'm going to be going over FRQs and their packet 6, which is still relevant, but you can still come in and ask questions if you want, or sit in on an AB session. Okay, so I'll spend a minute, see if you can read page 31. This is non-calculator, so keep that in mind. We'll do page 31 and 32 from 2018 before we move on to 2017. So for part A, we know that if we want to find the area of region R, we first have to do the outer region and subtract out the inner portion. So the outer region is just 3/4 of a circle. So if you think about from that perspective, 3/4 of a circle, I can just do, sorry, 2/3 of a circle. Since from pi over 3 to 0, that's going to be 60 degrees. That's another 60 degrees. So that's 120 degrees. So the remaining portion is just 2/3 of the circle. So I know my circle is has a radius of 4. So 2/3 of pi r squared, it's just 32 over pi, 32 pi over 3. You can write it in this form, but you can also just say, okay, it's 2/3 of a circle minus, and then I always prefer to go through, that's my preference, to go through symmetry. So I'm just going to just find half of the region that I need from pi over 3 to pi. And then I did 1/2 radius squared, and I just doubled it to take care of the third and fourth quadrant. Again, part A is just the setup. We don't have to, or we can have a mixture of value minus the setup. Okay, part B, find slope. So think of slope as dy over dx. dy over dx can be expanded into dy over d theta divided by dx over d theta. We can find each of our horizontal and vertical components. Find the derivatives using product rule, and then plug in replacing all the thetas with pi over 2. So part B, keep in mind, x is r cosine theta, y is r sine theta. If I replace r with 3 plus 2 cosine theta, I can distribute through and do chain rule, but I just kept them separate and did product rule. And part C is not too bad because it's just starting with our r equals 3 plus 2 cosine theta, and then doing related rates from there. Yes. Okay. Yes, that works. Good. Yeah. Okay, if we're good with 31, then go to page 32.
separation. Sometimes, when you have the point, sometimes you first do and
Solve for C and then solve for Y.
Yeah.
Yeah, yeah. I say, once I have my equation in front of me, I look at the path of least resistance. So I'm like, okay, does it look like an easy equation for me to solve for C? If it does, I'll go ahead and solve for C then. If it feels like I can just solve for C later. So
Okay.
there's no really rhyme or reason. I find that, if it feels easy enough to get it out of the way, then I'm going ahead and do it. But if it looks too complicated, then typically I would solve for Y first and then solve for C. But you can, yeah,
Either way works.
either way works. Yeah, just whatever. Yeah.
Yeah.
Like this, where it's like radians per second.
Mhm.
If like on the exam, if I just circle like the answer, would they pick off once? But not including like radians per second.
Let's see. Yes, whenever they say indicate units of measure,
Okay.
that means they will take off a point if you don't include it. Yeah.
Okay, thank you.
Mhm. Okay, if you're done with 32, then let's do 34 and 38. Want to get all the polar and series out of the way. Mhm.
I just wanted to know if you can use like the interval of convergence thing on like non-alternating series. I'm this one is not getting series, but like if there wasn't like the negative one, could use interval of convergence.
This most of the curious thing you've seen kind of fit.
I'll say yes, because in order, because when we do the ratio tests, we completely disregard the alternate signs, which is to a sub n plus 1 divided by a sub n. And if that is less than 0, or if that's less than 1, interval convergence. I want to say that it doesn't matter with the alternating signs, but you would think that with the alternating signs that you would have a wider interval of convergence. Yeah, but for now, I think I'm just going to say for now that regardless of alternating signs, it's still to ratio test.
What's alternating, but the interval thing is just ratio. That's the point.
Yeah, if it's alternating, then that just means that we can go through alternating series test. Which will make it easier for the series to converge. For Taylor series, it does have to be alternating, we can still go through ratio test.
So do like if it's an non-training series, like we still have to test the endpoints.
Yes, yeah, regardless of, yeah, we always have testing endpoints, yeah. I think the only time when the alternating and the non-alternating is going to come into play for us is if we're deciding whether to use Lagrange error bound or alternating series test, right? If we can do alternating series test for errors, that's a little bit easier, but it can only work for alternating series.
Sometimes like hard to find the next unused term, like. I mean, I don't have an example with me right now, but like.
I think, okay, with the, to find the next yeah, well. If we have the general rule, then just jump to the next term. And you can always ignore the alternator as well. The alternator has no play, has no say in what because we don't care if it's negative or positive.
Okay.
But, yeah, if you find an example, we can go over it, but I feel like if you have the general term, you just find that next term, next unused term. So region R is the inner portion. So the one that's closer to the polar, or for the polar 0, we don't have to worry about subtracting the S. But if we're trying to find region S, we got to find the entirety of this region and then subtract out that region R. So this is telling us the 4th degree approximation minus the actual value of the remainder. That's right, this is remainder, yeah. Anytime you see absolute odds, it's basically the fifth term, right? The fifth term is going to tell us the difference between the actual value and the polynomial approximation.
That makes sense.
It becomes a constant notion, right? Yeah, so you know it's a constant. First off, because any constant divided by zero, no leaf in it's being limit. Like, you know, it's considered for left, it's gonna be smaller than, it's gonna be like 0.9, right? 0.9. So 0.9 minus 1 or 0.9. Actually, negative over 10 is positive.
Thank you. Okay. Okay, thanks. This is 2019 FRQS. You just show this way. Thank you. If I just write one time. Equation. Oh. Often one of the solution gives that. Yeah, but I think we need to have some frame of reference, right? We have to involve pi over two somehow. It's half pi over two. So, like, we have to, pi over two has to be involved in the process. Otherwise, if we don't know what the full is, then there's no way for us to find the half. Right. So right now here, there's two missing variables there. You got missing variable A, you got missing variable K.
Oh, I see.
Because I already have, because I can figure out from 0 to 5/2. Yes, and that's fine. Yeah, if you put 0.168 over here, or you can do half of this equal to that.
And plus some.
Yeah, so somehow I get to fill in that left side.
I have to put something no.
Something no, that's right. There you go. Something no.
The degree wake up. And the only light source in my room is my alarm clock. It was so bright. It's so fun. I want just to be, I don't even know how this would affect me. When my clock was going on, I would really remember getting this.
Have a great day, guys.
Oh, thank you.
I appreciate it.
Thanks for going back.
Great.
But.
How many years has it been? 32 years. Wow. Thank you.
Last time they said that it was kind of hard. Yeah, I mean, it's like the last. I feel like it's one of my years. It's not hard.
Thank you. Thank you for that. Thank you.
Can I show you my work?
Yeah, show me the map. Yeah, thank you.
Yeah.
I'm shooting tomorrow.
Thank you. See you tomorrow.
Thank you, Mr. Ing.
All right, see you tomorrow. Thanks.
Yeah, I didn't sense kind of shit. Yeah.
Error.
Good morning, Motion students, faculty, and staff. Please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please pause for a moment of quiet reflection. Thank you. This is just a reminder that yearbooks will be distributed during all lunches today. Make sure to get the QR code from the email once you purchase the book. You don't have to print the code, just have it on your phone so that they can scan it. All books must be picked up by May 17th. Thanks. Have a great day.
Today?
I'm gonna finish up on packet 5 and just pick
Okay.
out problems,
Okay,
from 2016, 2018.
all right.
But,
That's the one we like still have from last week.
right, I can give you back.
Yeah, I'm just gonna go home and check the.
Sure.
And then tomorrow we get the 6th one.
Oh, I handed out the 6th one already.
Oh, yeah, can I grab that?
They're all down there, and that's what I handed out on Friday. That's the summary.
Okay.
Let me also get you the previous FRQ.
But then, so it's like from now on, I just like come to class. I'm not taking an exam and we'll just, or no class.
Wait, say it again?
I'm so confused on how, we have a regular schedule this week?
Yes, we still have a regular schedule.
Okay.
So I'm still gonna have class. I'm still going to do help sessions before school, after school,
Okay.
and advisements. So if you have any questions about packet 5 or 6, let me know. Let me get you this real quick here. All right. Okay. All this is in the grade book already.
Awesome. Thank you so much.
Yep.
All right, I'll have all 5 done tomorrow when I come.
Awesome. Thank
All
you.
right, thank you.
Oh, and then I'm gonna be checking 5 each day.
Okay.
So 2018 is due, 2019 is due today. Tomorrow's 2018, 2017, 2016. So you have until Thursday, but if you want to finish it up, you can. It's up to you.
Okay, I did slowly go on to class.
I got it. Yeah.
Okay.
Thanks.
Thank you.
It just wants us like, yeah.
Like, so. The dialogue,